Ladies and gentlemen, this is Ardwick, and after a few unfortunate incidents in the last video with the Goddard 3, I think we're about ready to move on. We've earned enough science to move on to the next step, which in my case I've decided is going to be satellite launching. Now, satellites can be done in a couple of different ways. For example, you can launch your own satellite aboard its very own craft, or so on. First, let's actually design our satellite. I will admit, I don't really know too much about satellites, so this is more or less just a test to see if I can actually do this in the first place. We earned this satellite piece right here, the Sputnik. That is sort of like the command modules, except this is unmanned, so we can control it from this. This is okay, but it's not really enough for us to actually do anything with it. First of all, we need to have this powered, so we need to provide power to it by means of putting on some solar panels, which we've also earned recently. We probably want to put on as many as possible. That should be good. We might even want to put on more for when it gets dark on the other side. Well, maybe something like that. Let's see if that's symmetrical. That's not bad. Let's see. The more solar panels, frankly, the better. I don't know if you need that many, but it's useful to have some. Let's see. Let's put some scientific instruments on it, because we're here to conduct science after all. I'm gonna put them right in between the solar panels, right there. Nice and evenly spaced out. I don't think we need that many thermometers, but, you know, symmetry, and we might be able to get more data from it. I'm not entirely sure how this all works yet, I'll admit, so this is mostly an experiment. Let's see. I've been told that you need to put batteries on it for when the power goes out. Can't put one on top. Let's see. Actually, I'm going to put these a little bit closer to the battery. I might even put them on the battery itself, just to see if that'll work just fine. Yeah, I'm going to put those on the battery. I'm going to attach a second battery onto it to see if that helps with the charge at all. We need to find some way to have this system communicate, so I'm going to put some antenna on it. I'm going to put some right there. And finally, we'll want a good way to tell if the power is currently on or off. I don't think we need to do this, but maybe for fun I can try putting something like a light on top of it. Pretty standard fare. If the light is on, that means that it is being powered. I'm going to put 2 lights on for symmetry. I'm going to put them as evenly spaced as I can. Maybe about there. It's not perfect, but it is a system. You know what? Well, okay. Maybe if I aim them down in front of the antenna. Oh, that just looks stupid. You know what? Never mind. I don't want to risk it getting in the way of the antenna. And actually, I'm going to put some more batteries on this too. Let's see if I can use them right in between. There. Now we have a ton of energy on this thing. Anything else we want to add to it? I guess if we have that much energy, we can afford 1 lamp. Or 2 for symmetry. Plop it right there. Before we actually launch this thing, I want to put it on the launch pad and see how it works. And I'm going to call this Mercury... There. 4. Right, there we go. Let's save that real quick and check it on the launch pad. We're not going to launch anywhere, obviously, because we've attached no thrust to this thing, so we're more or less just going to see how well this functions as it does on the launch pad itself. Let's see. We've got the Sputnik Mark 2.0. We have our headlamps, which we can turn on. They turn on individually, and let's see how much power that drains. Oh, none. Because, oh right, because of all these solar panels, we're still connected to the sun, or the sun's still shining on the panels. Therefore, we're not losing energy despite the lights being on. Let's see. Yep, it's still at 10 points, which means that the power is not draining down. If it were draining down, it would slowly be going down here. Let's check our thermometers real quick. Log temperature. Right, so we can log some science. We can transmit data at 50%. I think until I learn otherwise, I don't really know how to procure better data. So this is more or less just a test to see if it can transmit data, which it can. There we go. That drained a little bit of charge, but it still works nonetheless. So there we have it. Not too much, but we do have a working system, even if its only purpose is to actually collect temperature data. So, now that we have this, we need to attach it to a rocket so we can actually get it up in the air. Let's see. So the Mercury 4 is going to be similar to our other systems here. We're going to want to have a, let's see here, we're going to want to have a decoupler at the very bottom of this, because this satellite should be its own system on its own. We're not going to give it any thrust capability, so we're going to put it in orbit and it's going to stay there without adjustments to thrust, because it's just a basic satellite, similar to how Sputnik was. For those of you not in the know, Sputnik was the first satellite ever launched into space by the Soviet Union, I believe in the late 1950s. Since then, there were other Sputniks. I believe there was one called Sputnik 2, which famously carried a dog that unfortunately did not survive on its trip. Her name was Lakia, I believe. Very, bit of sad space news. Actually, not really news, but, sad space facts. There we go. Because of the fact that we have this on top of the nose instead of a space for the parachute, we're going to have to deploy a couple of parachutes here instead. In fact, just for safety's sake, I am going to put 3 of these guys on. Oops, that's 4. There we go, and I want them to be between the doors so that we can escape the hatch if we need to. Although that might not be feasible. Okay, we'll just do 2. By the time we actually land this thing, we'll have a small enough payload. Because so far... Oops, that's nothing. And right there. There we go. Okay. Next we need some science to go along with the main pod. In the last episode, we attempted to do a lot of science in upper atmosphere with this Science Junior, and it kept failing because the debris parachutes didn't deploy or some nonsense. There were a lot of other recordings that I tried to do and failed at doing because I was so mad that I hit the resave button a lot, which unfortunately happens to be right next to my stop and start recording button, so I have to be careful. We need 3 landers for this. We're going to put one right under the ladder so that if we do fall off, we do have a buffer. There we go. So this is... Oh, actually, we can put a little bit more science on this. I'm going to put some thermometers, in fact. One for the surface here. One for returning the upper atmosphere. Actually, hold on. Got 3 of these, so we should use 3. So let's see. We're going to do 1 on the platform before we leave. We're going to do another at the landing site where we eventually land. And we're going to do another one... I believe we're going to do another one in upper space. Let's see. Also, to power some of these instruments, we're going to attach some solar panels onto this device as well, directly beneath the thermometers. I don't realize if these are necessary, but I did do a launch earlier testing before I recorded, and I noticed that the capsule was running out of power by the time it landed, so it might be nice to have some solar panels to give it some extra. Anyway, this right here is, this is the main load. We've got the, satellite up here, and the lander and science project down here. Beneath that, we need everything else, including our upper stage, which we're going to use a static decoupler for. We're going to need a little bit more power to get ourselves through this because we have a higher payload to deliver, so we're going to use a bigger rocket and an efficient small booster. We're going to have to raise this up a tad bit. Don't forget, I've learned this last time, do not forget to put a decoupler between your stages. We're going to want a lot of power to lift this because we are lifting both a command module and we are also lifting a, let's see, 1, 2, 3, 4. 4 is good. We are going to want to use a liquid fuel engine, the most powerful one we currently have in the game. We also want to use these winglets, these new ones that we recently got. They are much better at turning than our previous ones. So we're going to staple them right on here, right about there or so. Finally, we need some additional boost to get us up to the orbit that we want to get to, because we are going back into orbit to release a satellite. Satellites orbit the Earth. Hence, we need to go into orbit to put it there. Finally, rocket boosters. We're going to put these right here. On our earlier missions, we did decrease the power of these. For now, we want them to be at full thrust because we have a long way to go. I believe that's how it works anyways. We're going to want to put some decouplers beneath them and our supports. And before we launch, I'm just going to save and check our staging. So the decouplers down here, the boosters that we've attached, and our initial main stage right down there should all be in the same spot. Those deploy next. Let's see, those deploy next. So we want, okay, we do not want this one to be here. We want this to be beneath that because this. Oh, never mind. I'm wrong. Because this has to deploy before we can launch this booster. If we don't do that first, this booster will achieve nothing. It might actually endanger our ship. Once we reach the orbit that we want to reach, we are going to decouple the, actually, we want to decouple this one first. So this is going to be the one that decouples after we have this one. So once we get into an orbit, which we'll use with this booster, we want to release our payload into a stable orbit, which this decoupler will do. When that decoupler fully detaches, we can then leave orbit and return home. We're going to want to detach from our stage down beneath us because it has a tendency to explode, and finally release 2 parachutes. So, we should be good to go. This is the launch of the Mercury 4 rocket. And provided it goes well, we will have our first satellite in orbit, our first permanent device to stay above the Earth, our first space mission, if you will. Our first permanent space station mission. To begin with, we're going to hit T, 3, 2, 1, and liftoff. Alright, so we see our satellite up there standing on top of our system. It might seem it's a bit strange to put it right on top of the rocket like that, but it's okay, it should be fine. When our solid rocket fuel starts to run out, we're going to use our liquid fuel about now. And release the other boosters. We're going to keep going until we reach 10 kilometers in the sky and then turn 45 degrees. We're going to turn either east or west. In our case, we're going to turn east because that should give us the most amount of boost. And because we want it to go into an equatorial orbit, not a polar orbit. Okay, so now we are slowly going to turn over, now that we have these boosters here where it's much, much easier to turn. And then I will release the turn command here. And stop. Okay, it'll adjust itself and stay at 45 degrees. Let's check our orbital map once again, because it looks like we've got a pretty solid launch. We're doing pretty good. We're going to keep going until we either run out of fuel in this stage, or we hit 100 kilometers. In fact, we're going to bring up our control wheel here, just so we can see where we're going. We're right on the 45-degree mark. We're doing pretty good. I believe if you want to, you can adjust it so that you're aiming a little bit lower, so that you have a sort of longer, but not quite as high archway. I guess we can do a little bit of that. Let's see how well that goes if I aim it a little bit further down towards this yellow crosshair node. That node is designed to help put us into orbit, so that might be useful to use. Now, the orbit that we're aiming for, it isn't any particular orbit that we're aiming for. We're more or less trying to see if we can put it in orbit in the first place. We shouldn't have any difficulty doing so. This is mostly a test, and stop. Okay, so the first part of our launch is officially complete. We have 2.5 minutes to choose our orbit. Let's maneuver here, zoom back out. Let's see. Well, a good orbit. Let's see, we've got 100 over there and 120 over there. So that's a pretty solid circular orbit. We can go a little bit higher. 101. Yeah, you know what? Let's not risk it. We've got a good setup here. I'm going to accept this orbit. We are going to quickly turn down, or rather adjust our orientation here so that we hit the blue node. Here we go, real quick. Before we get too high up, I want to actually initiate one of the... might be too late actually. I'm going to try to initiate one of our thermometers. Log the temperature. We are going to transmit that, because that is how we transmit from a system. So at the very least, we know that the satellite is operational right now, and we were able to transmit 4 points worth of data. Also, while we're up here, I'm going to turn on one of our thermometers. I'm going to log the temperature, and here I'm actually going to keep the data on board our own system. Oh, we are tilting a little bit too far south. We want to make sure we're stable here. There we go. So, we've logged some temperature and obtained a little bit more science. Perfect. And in fact, if we want to, we can also hit the toggle display on the thermometers, and that'll show us what the temperature is. This, I believe, is in Celsius, so right now it's displaying minus 40 Celsius, which is pretty darn cold. But then again, we are in space. 26 seconds to burn. And when we put ourselves in orbit, we will at long last release our brand new satellite. Ooh, this is exciting. Okay. 10 seconds to go. Finger on the throttle. 4, 3, 2, 1, and throttle up. That stage is spent, so we are going to ditch it real quick and initiate the next stage. Ah, this is so cool. Again, there are other ways to launch satellites. You can set them on their own rockets, but I think it's actually kind of more fun to put one of our own people up here and do like a deploy system. They used to do that with a space shuttle, actually. Back when we still had the space shuttle, what we did was we would launch satellites and some orbiters from it. Okay, so our Apoasis is going up, and pretty soon our other bit there is going to go up as well on the other side. We're going to want to make sure that it's about up to where we put our node right here. Oh, look at that. To 100, just a little bit more. You can do it. Nope, actually, you know what? We're getting too high on this side. Okay, so it's not a perfect orbit, but you know what? That's actually not bad either. Because if we have an elliptical orbit, we can do temperature measurements from down here, and from all the way up here as well. So that might give us the most amount of scientific data yield. At this point, we're going to go back to our staging. We are officially in orbit, and our satellite, I believe, is ready for launch, as long as we're satisfied with this particular orbit. So, I'm going to give it a go. If I hit the spacebar, the decoupler up top should detach, and our satellite will be released into space. Let's keep an eye on it. Let's see where it goes. 3, 2, 1, and deploy! Oh, the camera adjusted itself over there, but that's okay, because our satellite, our Mercury probe, is now on its way. If we go back to our orbit map and take a look at the orbit lines, you will see that there is now a second gray line. That is our satellite's trajectory. The Mercury 4 probe is now officially Kerbin's first satellite. In fact, now that we're in a safe orbit, we can actually go to the Space Center. And we can track the satellite on its own now that it's its own specific object. We're going to go to the Mercury 4 probe. Here we go. In fact, we can actually see our ship that we launched it from, the one that we have our astronaut in, still hanging out down there. He's going to be with us for a little while longer, but once we land, we're going to lose sight of him. Or once he lands, we're going to lose sight of this satellite. So it's time to do some science up here while we still can. Let's see. Let's log the temperature. Oh, well, at this point, it doesn't look like we can get any data from scientific, a return here. I'm going to wait until we reach the higher altitude of 300 kilometers and then try to do this again. Again, I'm not entirely sure if this is going to work. If it does, then we will have gotten new data from a high point. And if it does not work, well, we can still get temperature readings from our Mercury 4 ship. I am going to speed up time a bit so that we can coast over to our higher point. Now we're going behind the planet. Unfortunately, this means that we are going to lose power for a little bit. Oh, hold on. Yeah, here we go. It's not too late, though. I might still be able to conduct some science. Oh, no, we can't do it. Maybe it's because we're actually in the air like this. Or rather, not in the air, but behind Kerbal. So we're going to need to fast forward a little bit further now. We just need to go far enough to put our solar panels back into the sun. Hopefully that'll happen before we go below 300 kilometers. Oh, look at that, there we go. Our electricity is slowly coming back online. Let's see if we can log temperature now. No, we can't. Maybe our antenna need to be positioned towards the launch site? I'm not sure, admittedly. Let's try going a little bit further and seeing what happens. Before we dip below too far, let's try another thermometer reading. No, that one doesn't want to do it at all. Can we not do this? Cannot be done right now. Cannot be done. I guess we have to go a little bit further. Let's see if... Let's not worry about 300 kilometers anymore. Let's see if we can actually do this at all. No, it doesn't seem to want to do it anymore. Well, unfortunately, we don't seem to be able to get that much science up here. So instead, we are going to leave the satellite as it is. I am going to turn on the lights. We don't even need to turn on the lights, but it's fun to do. Plus, it's a good way to gauge our readings here. I was sort of hoping that the lights would illuminate the spacecraft a little bit, but it doesn't seem like they do. I'm going to turn the lights back off. The lights were kind of unnecessary for the spacecraft. Now, I haven't figured out exactly how to get energy, because we get energy transferred onto this system, and the energy is also connected directly to these battery packs, which should be powering these thermometers. But I'm not sure how to get that to properly transfer. Maybe there's someone in the comments who knows a little bit more about transferring data from satellites. If you guys happen to know, please let me know. If there's anything else that can be done with this spacecraft, by the way, please let me know as well. If there's anything else we can do with our first historical spacecraft. We are going to name this after the first satellite to ever be launched from the Earth. We're going to call it Sputnik, in honor of the Sputnik 1 spacecraft launched by the Soviet Union. Sputnik is now about as good as we can do with it now. We'll leave it and see if there's anything else we can ever do with it again. For now, we are going to leave Sputnik and return to our original launch vehicle, the Mercury 4, which is still currently in orbit. So we are going to land. We're not doing a polar landing this time. We are more or less just going to land wherever is appropriate. There's no reason to be picky this time. Where is this going to put us? 26? Around what appears to be desert, perhaps? I'm not sure what that is. I'm going to try to land right in the middle of that landmass, perhaps. Let's see. Well, no, actually, we're good. So, we need to initiate a burn to get us back to the planet. Huh. You know, what if I attempted to actually land us in the desert instead? Like, the place that I know where there is desert. So I'm going to try to actually plop us down on top of the desert, which should give us some more science yield. I do not have the goo experiments with me, though. I do not have the foresight because I thought we wouldn't have to land in a new spot because I didn't realize there were any more. But there is a desert, and that may yield more data. So we are going to try to land in the desert this time. We are going to readjust ourselves to correspond to that node. And we're going to wait 20 minutes. Let's check our trajectory once again. Ooh, we have lost our ability to go there. So we are briefly going to do a couple more burns by aiming ourselves up like this. And using, well, once we get past our re-entry fire stage, we are going to, again, let's see if we can't position ourselves. We're going to throttle up. Oh! Right, that's what the throttle is. We're going to do that. Power all the way up. And aim this way to try to land in the desert proper. I don't think this is working, though. We might just miss the desert. Oh, hold on. We're going up. We might make it. Oh no, we are going to be just shy. We are going to fail to land in the desert, but only barely. I think it's because we used a lot of burns to try to get here. We were just short of actually doing this. Oh well. We are going to release our other stage because we no longer need it, so it is going to enjoy a nice, horrible death. There is not much else to do at this stage other than to prepare for landing, so when we get low enough, I am going to deploy our landing gear. Let's see. Deploy our landing gear here. And I'm also going to deploy the parachute. So that should ensure a safe landing. Any more temperature readings I can get here? Temperature, we're going to save that temperature real quick. And we're going to land. There we go. We are now on the ground once again. We're going to reset the materials bay to see if by any chance we'll have a better opportunity to get some materials. Yeah, that's not bad. Any temperature readings while we're here? There we go. This would be a nice place to live, provided there were any other civilizations anywhere here on the planet. Crew report. Nothing of interest. And that gives us how much science now? 11 science. I believe most of that came from the temperatures. The temperature readings. And a little bit of material study. Not bad, I guess. Let's see. Our tracking station also shows us our satellite, which we have launched. If we were to click it and didn't want the satellite anymore, we could hit the terminate button to get rid of it. But we are not going to terminate it. It is a historical craft, and we're going to leave it there for it to be for all time, or at least until something happens. If you guys have any suggestions for what we could possibly do with the craft, I don't want to terminate it, but if you guys have any other ideas we could do with it, please let me know. I'm not sure if any of you guys are familiar with the Kerbal system, but maybe there's some advice you can give me that I don't understand. So, let's see. We should be good to go. Can we earn anything with our science yet? Because if we can, I would love to earn something new. Ah, here we go. General Rocketry. We're going to want this because it gives us a new fuel engine and the boosters, which we need to get to the next level. So I'm going to take this, and with that, we should have everything we need to move on to the next steps in the game. Until then, everyone, this is Ardric of Anet. Stay tuned, and good night.